Okay, I like catching things in action, and here is an example of that. You see a giant wave has just come in. Actually, the one previous to that was even bigger, and it overtopped this slight rise, so it couldn't go back to the ocean. So it had to seek its own level, like water does, and there were some pre-existing depressions from previous times, so it just flowed in those depressions very, very slowly, meandering courses. Check this out. Here's the remnants of that wave about to find its way to an already existing inland sea. So it's going to partially refill it. Just one wave is going to partially refill this already existing inland sea. You see that, right? So it's already made a 90-degree turn, and now it has found its way to that inland sea. This inland sea eventually will fill up as you get more and more of these waves coming in, overtopping, refilling an inland sea that had already been here. Let's go to the end of this inland sea. And oh, by the way, there's an oopart. Oh, but we'll forget about ooparts, because ooparts by themselves destroy the idea of evolution. Anyway, so we have this inland sea that's slowly refilling, running parallel to the ocean. So it's running parallel to the ocean. It's coming in, refilling. As it fills up, it too is eventually going to fill up to the point where it has to find some avenue back to the ocean. So you can see that as high tide occurs and this fills, here's a slight rise, but then there's another inland sea. At one point they were one and the same inland sea. This one's pretty well drained because it has found a way back to the ocean. Okay, it's found a way back to the ocean. So this one has basically already pretty well drained. Now, this was a slow process. Right here you can see that some of the main flow, it's very difficult to see perhaps, but some of the main flow already made a U-shape, a horseshoe as well. So again, it's just a matter of scale. What started out down there a couple of 100 yards, it seems huge to people because we're so small. But to God, Grand Canyon is just a drainage ditch. It's just a drainage ditch. A pretty drainage ditch, I'll grant you. And one that was formed under special conditions that have pervaded to this day. Yet another way that horseshoe flow could occur. Here you can see a very slight depression, but here's some organic matter, a big blob of kelp. The water has flowed around it in a horseshoe shape, in another blob of kelp. Here's two complete horseshoe shapes, three complete horseshoe shapes. And then, when water gets high enough, it's going to come down here. There's a slight path back to the sea again. So you can have any number, and then if you join this up with, well, there's one inland lake, there's a very small one, there's another one, there's one more. Eventually all of these get joined up, and you get a series of very strange U-shaped turns based on sand dunes, based on blobs of kelp, based on mounds that have just built up that one day will turn into table mountains. Miniature table mountains here. Here's yet another inland lake. So in just 300 yards, I'm walking through three shallow inland lakes that all will find their way eventually. They'll fill back up when the high tide comes in, high tide goes out. They'll reinforce the already existing trenches and gullies. Eventually, the oceans will sink down and they won't fill up anymore, and all of this will harden and then erode from there Boom, we have Grand Canyon.